Inverse functions are functions that undo each other. So a classic example, an inverse function undoes. Classic example would be f of x equal to x cubed, and then we use the notation f inverse of x would be equal to the cubed root of x, or x to the 1/3, both meaning the same thing. If you plug a number into the left function, like you plug 3 in, you get 3 to the 3rd power, or 27. Then if you take 27 and plug it into the right function, you get the original number 3 again. They both undo each other, but there are a lot of misconceptions about inverse functions. One example, this would be a similar one from the notes, similar to number 3 in the notes. I'll make a few changes. Would be to say f of x is equal to 1. The domain of this function would have to be 3x minus 1 is greater than or equal to 0. The range of this function goes back to the range of any radical function. If we plugged in 1/3, we would get the square root of 0. And given any value for x, it's impossible to get a y value that is less than 0. Our range would have to be y is greater than or equal to 0, and you can confirm that by graphing. If we take this function and change it to y is equal to the square root of 3x minus 1, we find inverse functions by switching the x and the y. We can change that to x is equal to the square root of 3y minus 1 and solve for y. Let's square both sides of the equation to get x squared is equal to 3y minus 1. Add 1 to both sides to get x squared plus 1 is equal to 3y. Divide both sides by 3 to get y is equal to 1/3 x squared plus 1/3. Now, this has the function the way it's written. We can change that to f inverse of x, but we have a slight problem here because what's happening is that the domain of this function is all real numbers. We can't have that because the domain of the function has to match the range of the original. If the range of the original was y is greater than or equal to 0, we now have to say this is only for x greater than or equal to 0. Then if we plug 0 in for x, we can see that we get 1/3 for y, and you can figure out that your range here, since this is a parabola with 0 negative, or it's a parabola with 0 1/3 as its vertex, and that's a minimum, we know that our range would be y is greater than or equal to 1/3. Now we're pretty confident that since the range of one matches the domain of the other and vice versa, we have an inverse function, but that has to be defined with a domain of x is greater than or equal to 0.